The modulo operation, which involves determining remainders. Alright, so the process or operation of calculating the remainder is known as the quote modulo operation. Here's a mainstream wiki definition of it. So in computing, the modulo operation finds the remainder or signed remainder after division of one number, so sign includes a positive or negative, of one number by another called the modulus. So if you divide a number by another one, the divisor is the modulus of the operation. Given two positive numbers, a and n, a modulo n, abbreviated as a mod n, is the remainder of the Euclidean division of a by n, where a is the dividend and n is the divisor. And yeah, Euclidean division, just what we were dealing with earlier. Yeah, so thus the remainders of the previous calculations can be written as 11v equals 1 plus 1 is equal to 2. 11 divided by 9 is 1.222. Again, there's a 2 over 9 is 0.2222. Or you could write 11 mod 9 equals to 2. This is the remainder. And it just so happens it's the exact same thing. And here's the automated built-in calculator. Just type equals 11 mod 9 equals that. That's the same thing as writing 11 divided by 9 and finding the remainder. And similarly here we have 6, 7, 8, v equals, this is 6 plus 7 plus 8 is 21, v equals 2 plus 1 is 3, and then 6, 7, 8 divided by 9 is 7.5, 75.333, 3 over 9 is 0.333, or you could just write 6, 7, 8 mod 9 finds the remainder. And it's always 3. Yes, it's always the same thing. The remainder, and hence mod 9 in base 10, appears to be always equal to the vortex sum. Note 1. The only issue is that when a number has a digit sum of 9, or a vortex sum of 9, the mod function will give a remainder of 0. For example, if you have 1 plus 8, if you have 18, v equals 1 plus 8 equals 9. The problem here is 18 mod 9 is equal to 0, because the remainder is going to be 0. So this is the only case that's different. But yeah, so in vortex math, I'll just put this as vortex so we're all understanding what we're doing here. So if it's 0, we just have to set it to 9. Note 2, typical convention for modulo operations is as follows. 12 mod 3 equals, 12 mod 9 equals 3 can be written as, actually here I forgot to show this calculation. So you write equal and it goes to 0. 12 mod 9 equals 3 can be written as 12 equals 3 mod 9. Yeah, in other words, some people write it like this. They would write, instead of writing 12 mod 9 equals 3, some notation or some convention is written as 12 equals to 3 and then in bracket mod 9 to show that it's a remainder after dividing by 9. But I prefer this one right here. And here actually to provide more info, I just rewrote this. And for the purposes of this vortex math video, I'll use the same quote v equals notation used for the vortex sum, since they are since they're equivalent or equal, except when the modulo equals 0. That's the only issue. We'll have it 9 for the vortex sum, as in the proof in the and as in the proof, or better yet, which I prove in the next section below in this section right here. So we could write this as 12 mod 9 equals 3 can be written as 12v equals 1 plus 2 equals 3, or yes, 12v equals 3. The vortex sum is 3, so they're equivalent. So proof: the vortex digit sum is equal to the mod of base minus 1. The modulo function allows for quickly determining the remainder of very large divisions. So yeah, the modulo function allows for quickly determining the remainder of very large divisions. So let's compare the vortex digit sum with mod 9 of very large numbers. And again, we're looking at mod 9 because base 10 is, so base is 10, 10 minus 1 is 9. So if we look at 1, 2, 3, 4, v equals to 1 plus 2 plus 3 plus 4, which equals to 10, and you can just press equals 10 and then v equals 1. So 1 plus 0 is 1. And then, or you could just type in 1, 2, 3, 4 mod 9, and it gets you the right answer. Equals 1. Or if you have 7, 7, 7, v equals 2, and you add these all up, it gets 21. So you have 7 times 3 is 21, it goes to 3. Or you could just write 7, 7, 7 mod 9 equals 3. And likewise, you can go 11, 1, 1, 1, v equals 1 plus 1 plus 1 equals 3. Or you can go 1, 1, 1 mod 9 equals 3. Again, type it in, equals 3. You can also go 9, 9, 9. V equals 9 plus 9 is 27. So again, this should equal to 0. This equals to 2, the vortex sum. But if you have mod 999 mod 9, remainder is 0, so it's 0 as expected. So only this scenario they're not equal. But we can just set it as equal to 9. So notice that the vortex digit sum is always equal to the mod 9 in base 10, except when it's equal to 0. Let's put that here. Except when the modulo is equal to 0. In fact, it is always equal to the mod n minus 1, and again, just outside of the, except when it's equal to 0. Always equal to the mod n minus 1, where n is the base number system. Note, I will look to do a formal proof in a later video, but the general proof below suffices for this video, because I usually make it super general. But this one is just a general number ABC, but you can expand it to A, B, C, D, F, G, H, just infinite. But yeah, I may do a more mathematical formal one, but this is pretty good still. So for a general number in base 10, let A, B, and C be any integer between 0 and 9. Thus, the number ABC is equal to... whoops, I already have these. These are my notes. Let me just delete that and start again. Yeah, so that's my notes. I usually do a write-up before I start filming. And then now I do it live. So let's go A, B, C. So this number. So if you have the number A, B, and C, so it's A, B, C. This equals 2. Well, you can expand this out as A times 100. Again, that's the 100th term, or the 2 zeros and then the A there. So again, these are the exact same thing. Imagine it was number 2. It would just be 2 times 100, or 200, or A 100. And then this is going to be B10, or B0, or just write this as B times 10. Then plus C. C times 1 is just C. And now we do the same thing as before. So we have A times divide. This one's going to be 99 plus 1. Yeah, this is 99 plus 1 times A. Then the next one is going to be the same thing. It's going to be 9 plus 1. Again, we're dealing with base 10. Like that, and a plus C. So you could always do this, and you always have that 1. So that means you're always going to be summing up the digits in the remainder. So 8 times 99. Like that, and then plus A. I'm just going to move the A over to this side, so we're going to have a plus A right here. And then this next one's going to be plus B times 9, and then plus B. Let's move it all over here. So it's going to be equal to plus A, plus B, plus C. So what we get is, well, we get this part right here. This is a factor of 9, because there's a 99 and then a 9 there. Factor of 9. That means you could just divide by 9 evenly in a whole number. And then this is going to be the first digit sum. This is the remainder. Or I'll just put the first digit sum. Digit sum. Then we could repeat the process. Yeah, then we could repeat this process right here. So we could go first digit sum. I'll just put it like this. Repeat process, and just put it like that. Repeat, this equals to ... Just change up the arrow. So repeat process if this digit sum, so this is, I'll just write this as ds. If ds is greater than 9. So in other words, we're going to write this as a factor of 9 plus another remainder, and eventually we're going to get a ... equals to a factor of 9. Doesn't matter what it is, it's going to be a factor of 9 when we separate the remainder, and then plus a remainder here. Like that. That is less than 9. Yeah, so what this means is this remainder, this final remainder, is just going to be the same digit sum. So we're going to be continuously adding the digits non-stop, and this is just going to be digit sum. And then, this is digit sum when this is going to be less than 9. In other words, this equals the vortex sum. Because we just continuously repeat the same digit sums, A plus B plus C, and so on, until we have a digit sum that's less than 9, which equals to the vortex sum. Yeah, so thus, the remainder, again, when it is not equal to 0, is always equal to the vortex digit sum, and we can obtain it by dividing the number ABC by 9, or the n minus 1. the base n minus 1, or using the mod function to calculate it, which is the number 9. So remainder equals digit sum until it is a single digit less than 9, which equals to the vortex sum. And then if we have ABC, this is equal to a factor of 9 plus remainder. ABC divided by 9, if we divide it, we're going to get a factor of 9 divided by 9, which is a whole number. And then it's going to be plus remainder divided by 9. In other words, calculating this remainder, we could just use the mod function, which automatically calculates it using its own algorithm. So ABC mod 9 equals the remainder. Note again, when the remainder is 0, the vortex sum is 9. We said that. That's the only difference. For any other base system, yeah, we could do the exact same thing, but we're just going to let p equals n minus 1. So for any other base system, let n equals base, p equals 1, and then we'll go abc, or any integer between 0 to p. Thus, number abc for a general base n number system is, and we could just do exactly the same thing as we have here, but replace the p with, the 9 with a p, or just mirror this 9 into a p. So let's do this quickly. Yeah, just to ingrain it into our brain. So we have A, B, C. This equals to A times 100. This is going to be B times 10 plus C. Because remember, the 10s are always, it depends on the number system. So those are just placeholders. This just equals to A is just going to be A times 1 plus P. And then plus here we're going to have B times 1 plus P. Plus C, this equals to, as always, A times P, plus B times P, plus, and then these A, when you, we have an A times 1 and a B times 1, as always, it's going to be A plus B plus C. And then this right here is going to be a factor of P. And then this right here is the digit sum. Sorry, digit sum. And then we repeat the same process. This equals to dot dot dot, and this is going to be a repeat. Yeah, repeat process. Repeat process until digit sum ds is less than 9. This is d dot s. And then what we end up having is just a factor of p, and then plus a remainder. And we can solve this remainder by dividing. Alright, so once again, the remainder, when it's not equal to 0, is always the vortex digit sum. That is ABC mod P equals remainder, which equals digit sum of A plus B plus C until a single digit remains, which equals to vortex sum. Because again, this factor of P, when we divide ABC divided by P, if this is a factor of P, that's just going to be a whole number. So then the remainder is this remainder right there. Now let's put that for completeness. So we have ABC divided by, let's move this over here. So ABC divided by P is equal to, well, factor of P divided by P, and then plus remainder divided by P. Yeah, so there's the remainder, and then the ABC mod P gets that value. The remainder, which is a digit sum A plus B plus C until the single digit remains, which equals to the vortex sum right there.